Hello everybody again. We are continuing with our study of analytical geometry. So here we are introducing a new term gradient. Firstly, we need to know what the gradient is. A gradient is nothing but the slope. The gradient is it is the slope. The gradient is the slope of a line. Let me just say it's a slope of a function, because even this line has a this curve or function has a gradient. Even this one has a gradient. So all functions have gradients, but we're not there as yet. We'll also do trigonometry, but for now we're still focusing on analytical geometry. So I don't remember myself seeing any curve here, but lines. Okay, so the formula for the gradient is this one. This here, let me pick another color pink. This here is the formula for the gradient. This m represents the gradient. So the gradient is usually given by the letter m, or denoted by the letter m. So here are some properties of the gradient. So the gradient m is equal to the change in y over the change in x, which is y2 minus y1 over x2 minus x1. So the gradient of a line, I should not have cleaned up that part. Okay, I will just use the one there. So let's focus on this line. This line is parallel to the y-axis. This is not drawn to scale, but you get what I'm trying to say. This line is parallel to the y-axis, and the gradient of this line is undefined. Remember, here x is 0. X is 0 here because if x is 2 here, then x2 is 2 and x1 is 2 as well. So focusing on this formula, m is y2 minus y1 over x2 minus x1. So maybe we can have some points here, y2 and y1. Let me substitute a and b. If y2 maybe is a minus, then y1 is b, making some example here. Then x2 is defined only on one point here, x. So if x here is some number, say c, that means we're gonna have c minus c, which is equal to 0. So we cannot have a 0 denominator. Immediately we have a 0 denominator, then that means everything there is undefined. Okay, so what happens when we have something like this? Is our Cartesian plane. These are the x-axis and these are the y-axis. Then we have this line here. We have this line such that this line is parallel to the x-axis. This line is parallel to the x-axis. So the gradient of this line is always 0 because m is equal to y2 minus y1, we know that, over x2 minus x1. Then we don't know what are the values for x2 and x1, so let's just say maybe x2 is equal to b, then x1 is equal to a. I'm picking some random letters or numbers. So y here, our y is, if this point here is equal to c, then our y here is c, our y here is c, our y on this line is the same. So that means we're gonna have c minus c, which is equal to 0, and 0 over anything, 0 over anything is the same as 0. Hence the gradient of this line is always 0. Okay, now let me erase and explain another thing, so that then after this video I will do some practice problems. Not really after this video, but as soon as I'm done with this, because I'll continue after this video, I will do some inclination. So the gradient, these are the properties that you need to know. The gradient of parallel lines, the gradient of parallel lines is always equal. The gradient, or the product of the gradient of two perpendicular lines, has to be equal to 1. So if maybe we have this line and this line, then saying this is AB, this is CD, such that AB is perpendicular to CD, then the gradient of AB times the gradient of CD has to always be equal to -1. Always this is going to happen. This is what is said by this property. This is what is said by this property here. Then about the collinear points, many of many of the things that I'm talking about will make more sense when we are dealing with examples. So about the collinear points now, look at this line drawn here. This line A, B, and C. A, B, and C are collinear points. If I have a line, then I have this point, this point, this point, this point. Then all these points are collinear, and the gradient here is the same as the gradient here, as the gradient here, as the gradient here. And that was it about the gradient. Now let's go talk about the angle of inclination, as we will be still continuing with the gradient. Then after that we will do some practice problems, plus the equation of a straight line. Let me introduce the equation of a straight line. This here, y is equal to mx plus c, is known as the equation of a straight line, or the linear equation, where this m here represents the gradient. So if I give you this line, let's say I say, okay, this line is g of x equal to 2x plus 1. Let's say I ask you, what is the gradient of this line? Just know that, oh, the gradient of this line is this 2. And thank you very much.